Now previously we have looked at two types of chemical bonding, ionic bonding and covalent bonding. So from this point onwards we are going to look at more of what kind of compounds or what kind of substances do they form, and what is the structure and property of these substances. Just to recap, there are two kinds of chemical bonds, ionic bonds and covalent bonds. Ionic bonds are formed when a metal transfers electrons to a non-metal. So basically when a metal combines with a non-metal. A covalent compound is formed when two non-metals combine by sharing electrons. Alright, so as mentioned in this lesson, or from this lesson onwards, we are going to look at the structure and properties of the ionic and covalent substances that are formed from such bonding. Now what exactly do I mean by structure and properties? By structure, it means how the particles are arranged in a substance. For example, let's say I have a sodium chloride crystal in my palm. Alright, sodium chloride is an ionic compound, since sodium is a metal and chlorine is a non-metal. So by structure, it means if I were to zoom in, I were to zoom into this crystal, and I zoom in until I can see the sodium ions and the chloride ions. The way in which the sodium and chloride ions are arranged in a crystal is known as the structure. Right? Similarly, let's say if I have a balloon that is filled with carbon dioxide gas. Alright, so this is a covalent compound, since carbon is a non-metal and oxygen is also a non-metal. Now if I were to again zoom in to the carbon dioxide in the balloon until I can see the individual carbon atoms and oxygen atoms, how they are arranged is what it means by the structure of the compound. Okay, next, properties. Once we know the structure and the bonding of the particles in the compound, it will allow us to predict the properties. It will allow us to explain the properties of these compounds. Alright, so we'll see later what are some properties, for example melting point, boiling point, solubility and electrical conductivity associated with ionic compounds and covalent substances. Now back to the part where if I were to zoom in to a crystal of sodium chloride, and I zoom in until I can see the sodium ions and the chloride ions, right? This is what you will see. Alright, how do I describe a structure like this? This is only part of structure, so that it is extended indefinitely in all directions. Okay, so there are millions of, or more than millions, there are many sodium and chloride ions extended in all directions. That is why we call it a giant structure. Okay, by ionic, why do we call it ionic? Because it is made up of positive and negative ions. Alright, and what does lattice mean? Lattice means a regular repeating pattern. Okay, if you look at the structure that is drawn, I hope you can see that there's actually a pattern. What is the pattern? The pattern is that the ions are arranged in an alternate manner. Alright, so a plus ion, a positive ion, is paired with a negative ion, and so on and so forth. Alright, so therefore this kind of structure, when we zoom into an ionic compound, we will see a structure looking like this, and we call it a giant ionic lattice structure. Alright, please remember the name for the structure. Alright, so before we go on, all ionic compounds have giant ionic lattice structures. Okay, now back to the question, why would the ions be arranged in an alternate manner? Why do we have to arrange plus minus plus minus? Why can't we have two positive ions arranged side by side? Alright, because in science, in nature, opposite charges attract. Okay, so plus and minus attracts. and like charges repel, right? So when the ions are arranged in this way, the whole structure is held in place by this attraction. And what do you call this attraction again? They are the strong electrostatic forces of attraction between oppositely charged ions. Alright, so this is essentially your ionic bonds. Alright, so now based on the fact that they are strong, okay, based on the fact that they are strong, the ions, you can imagine that the ions are very strongly attracted to one another, so it will require a lot of energy to separate them apart. Alright, with that concept in mind, that will help us predict some of the properties that we're going to see later. So as mentioned, there are three properties that we are interested in: melting point, boiling point, solubility, and electrical conductivity. Let's look at each one at a time. So melting point, boiling point. In order to melt or boil an ionic compound, we need to move the ions further apart. Alright, so that means that we need to overcome the strong electrostatic forces of attraction. And as mentioned, since they are strong, you will require a lot of energy in order to move the ions further apart. Alright, so with that you can predict that ionic compounds have high melting points and boiling points. For substances with high melting points, at room temperature, you can imagine that they exist as solids. Alright, so most ionic compounds exist as solids at room temperature. Okay, next, solubility. Now one way to memorize the properties of ionic compounds is to tag it to a model compound. What do I mean by that? For example, what is a common ionic compound that you can think of in your daily life? Right, most students will be able to tell me sodium chloride or your kitchen salt. Alright, so think about it. The salt that you see in the kitchen, what state is it found in at room temperature? It's in solid state, so that means that it has a high melting point, boiling point. Alright, the next question is this: will your kitchen salt dissolve in water? Answer is yes. Alright, so ionic compounds, most of them are soluble in water. Okay, there's another type of liquid that we can dissolve things in other than water. It's called organic solvents. Alright, for something that's soluble in water, it will be insoluble in organic solvents. Okay, what are some examples of organic solvents? It will be like ethanol and hexane. Okay, all these are liquids that contains carbon atoms in there, so we call it organic solvents. Okay, lastly, electrical conductivity. Now for a substance to conduct electricity, there are two conditions that must be met. Alright, first condition, it must contain something that is charged. Okay, it must contain something that is charged. Second, the charged particles, the thing that is charged, must be able to move. That means it must be mobile or it must be free. Alright, so let's look at ionic compounds. Okay, if you think of the structure that you saw just now, does it contain something that is charged? That means, does it contain something that has a plus or minus? Answer is yes. Alright, now in the solid state, are the ions free to move? Think about your kinetic particle theory. In a solid, are your particles free to move? What is the movement like of your particles in a solid? The answer is that they can only vibrate about their fixed positions, meaning they cannot move freely. Therefore, in solid state, all right, ionic compounds cannot conduct electricity. Okay, so even though they contain something that's plus or minus, something that's charged, but they cannot move, they are not free to move. Therefore, in solid state, ionic compounds cannot conduct electricity. However, if you think about it, if I were to melt it in molten, all right, or if I were to dissolve it in water in aqueous state, okay, if I were to melt it or dissolve in water, now the electrostatic forces of attraction would have been overcome, meaning the structure is no longer there. The ions are simply swimming freely, either in the liquid state or in the solution. Alright, now can the ions move freely? Answer is yes. Alright, so in molten and aqueous states, ionic compounds can conduct electricity. Okay, so you see, by knowing the bonding and the structure of ionic compounds, we can actually use it to predict, or we can actually use it to explain the properties of ionic compounds. Alright, so these are some common questions that you will get in almost every exam that you sit for. Alright, so and here are some of the standard answers given to you, and I'm going to point out the important phrases or the keywords that must be present in your answer. Okay, as mentioned, ionic compounds have high melting point, boiling point. Alright, for these two questions, they actually mean the same thing. When something has a high melting point, boiling point, it will exist as a solid under room conditions, and vice versa. Alright, so to explain why ionic compounds have high melting point, boiling points, usually I would recommend that you write out the structure first. So you show the marker that you know that we are looking at a giant ionic lattice structure. Okay, next you have to mention that you have a lot of energy, alright, or a large amount of energy is required to overcome the strong electrostatic forces of attraction between oppositely charged ions. Okay, the common mistakes that students make is this. Students will say that more energy is required. Okay, this is not correct. More is a comparative term. Alright, when something has very little when there's very little of something, and then I have slightly more, does it make it a lot? Answer is no. Alright, so the common mistake that students make is to say that more energy is required to overcome the strong electrostatic forces of attraction. This is not correct. You have to say a lot or a large amount of energy is required. Okay, another common question would be why do ionic compounds not conduct electricity in the solid state, and why do ionic compounds conduct electricity in the liquid or aqueous state? Alright, for that you need to again, if you want to, you might want to state that it has a giant ionic lattice structure. Okay, so in the solid state, the ions are held in fixed positions, okay, by strong electrostatic forces of attraction. Therefore, there are no free mobile ions to carry charge. Okay, in an ionic compound, the thing that's plus or minus, alright, is your ions. Alright, so when your ions move, a current is generated, or rather, when you pass a current through, the ions will move to carry the charge. Okay, so in molten or aqueous state, the electrostatic forces of attraction have been overcome, so now the ions can move freely. Okay, a common question that students will ask is there a difference between free and mobile? They are same but different. By when we say that an ion is free means that it's not in a fixed position, which also means that it can move. All right, so free essentially means that it's not bound, therefore it can move. All right. Now, as mentioned, these questions are very often tested in any exam that you sit for. Alright, so please make an effort to memorize the answers for the FAQs that you see here and in the subsequent lessons as well.